So, okay, we're going to do two things today. The first one, we're going to do the tables and graphs, and then we're going to put it all together and actually write the equations. But first, we're going to do tables and graphs. So today's the 26th. Okay, so basically, we're going to work on a table of values and then sketch the domain over a specified domain. So, first question, what's domain? Come on. Chase. Yeah, absolutely. The domain is all the x values that it hits. Okay, so when you're talking about like our first function here, okay, that's like saying we want to be from -5 and it includes it and it goes up to 2. That's basically our domain, right? Because that's the numbers it's hitting and talking about. Agreed? Okay, so we're going to use those to actually graph the function. All right, so we're going to use these points for the first equation. Why did I pick points from -5 to 2? Did I just arbitrarily pick those numbers? Why didn't I pick -100? Because they're in the domain. Exactly. Those were within the domain. And at the -5, all I got to do is put it into my equation. So 2 times -5 gives me -10. That's like my ordered pair, a -5, -10. And since it includes -5, because it's less than or equal to, I'm going to have a solid dot. Agree with me on that one? Okay, and then we're just going to do it for each of the other points. So I have 2 times -3, that's going to give me -6. And 2 times 0 is 0. And 2 times 1 gives me 2. And then 2 times 2 gives me 4. For this particular function, does it include 2? No, because it's just a less than, right? So I'm going to use an open dot at my 2, 4 point. Everybody with me? All right, so let's just plot points. So at -5, -10. Oh, sure. I got a closed dot. Okay. Then I'm going to use -3, -6. And I'm just going to put a little dot there. I don't need a great big whether it's open or closed. It's just one of the points on the line because that's what I'm trying to get a feel for. What does this line look like, right? And then I'm at 0, 0. And I have 1, 2. And then my last one was at 2, 4, and I have an open circle for that one. Anybody remember where she sits now? Oh. Thanks. All right, now connect my dots, and there's my first graph. Good. Okay, so the next one, my domain is from 2 less than or equal to x, which is less than or equal to 6. So that means that at 2, I'm going to have a closed dot because it's less than or equal to. And my function says, hey, if it's just any of these numbers in that domain, your y value is 5. So that gives me a point of 2, 5. Okay? So 3 is within that range or that domain, so it's a 5. 4 is in that range, so my output's 5. And 6 is in the range or domain. So I get a 6. So 6, 5. What's that line going to look like? Is it going to have a slope? Is it going to be horizontal? Is it going to be vertical? Horizontal. All right, so let's plot the points. I'm at 2, 5. I have a less than or equal to, so I have a closed dot. And then I'm going to go over to 6, 5. And it also is a less than or equal to, so another closed dot. And there's my graph. Easy peasy? Feel good so far? All right, so let's think about some of these for a minute. So we graphed. How many pieces does a graph have? 2, right? Why does it have 2? Anybody, somebody. I know it's new seats, but okay. Yeah, because there's 2 equations. Okay. Are the pieces rays or segments? First question, what's a ray? Anybody remember what a ray is? It's a line that goes forever, but there's something specific. It's more than a line. It is a line, but it's a specific line. At what? Closed. Yeah, it's got an end point. Okay, so a ray has an end point, but continues. Oops, continue. I can't spell today. The other direction to infinity or negative infinity. Okay? So then what's a segment? 2 endpoints. Has 2 endpoints. Perfect. Okay? So are these segments or rays? Yeah, they're segments. Okay? Okay, so how could I tell just by looking at my domain if I'm going to get a segment or a ray? What are my domains for these? Whoops. My domains for these 2 have specific points on each end, right? So, if it's a segment, you have 2 specified points in your domain. If it's a ray, you only have the 1 point. So for instance, x is greater than 3. I have an endpoint at 3, and then it's going to go to positive infinity. Okay, we're going to talk about that more. All right, so my endpoints, solid dots or open dots or some? Some, right? And it's because you have open for less than or greater than, and close for less than or equal to, or greater than or equal to. Okay, so do you think we needed to do all of the x values to be able to graph this? Like on the first one, do we need 5 points to be able to get this line? No, not really. We could have graphed it with less points, right? Which two are the most critical?
First and the last.
Yeah, our two endpoints, our domain points, right? So our first and last, or the two endpoints, whichever you want to call it, absolutely. Okay. I personally like doing a third point. So we do the endpoints, but I like a third point in the middle just to kind of verify it's a linear equation. Just to kind of verify, just to make sure it's like my graph is good. Okay, does that make sense? Feeling okay about these? Alrighty then, let's do another one. Okay, so I have an f of x where x plus 3 from negative 8 to 1. Okay, so that means from negative 8 to 1, and I'm going to have a closed circle and an open circle. Would you agree with that? And isn't that kind of like what my line is going to look like on the graph? Right? That's what it's going to the image. So let's look at negative 8 and 1. So negative 8 plus 3 gives me negative 8 and negative 5. And 1 plus 3 gives me 4, so I have a point of 1, 4. Good? All right, so let's graph negative 8, negative 5. I got a closed dot, and over 1 to 4 with an open dot. Does that give me enough to be able to graph it? I mean, technically, yeah. You could do a point in the middle. Let's say I want to do, let's see, what's between 1 and 8? I don't know. Let's say negative 2. Just to make sure. So I would have negative 2 plus 3. That's going to give me 1. And that's definitely on that line. So I'm good. You don't have to really. I like to check myself just to make sure. Okay. Now, go back in your memory banks to set notation. Okay, to show them domain. Do you remember what set notation looked like? Where x such that, remember that part? What would I put for the constraints or for my domain? Just my negative 8 It's the same thing. Does that ring bells? Does that make sense? All right, let's do the next one. So, from 1 to 7, and they're both including, so I got 2 closed dots. Those are the 2 points I'm going to use. So 10 minus 2 times 1 gives me 8. And then 10 minus 2 times 7 is going to be negative 4. So I have the ordered pair of 1, 8 and 7, 4. Okay? All right, let's graph that. So I have 1 and 8, and that was a closed dot. And I have 7, negative 4 closed dot. And there's my piece. And we have both segments. Now, question for you on number 4. Was it necessary to evaluate both pieces of the function for the x value of 1? What do you think? Jordan, you say yes. Why? Because they're included in both. Yeah, exactly. They're included in both, and so we have to use the different equations. And actually, because that one's not included, we got 2 different points, okay? So we definitely did. So it was included in both domains. All right, one more and we'll do some practice. Okay, let's look at 2x minus 5. X is less than 4. Okay, so let's use 4. And I have 2 times 4 minus 5. So 8 minus 5 gives me 3. Okay. So I have, is that going to be an open or closed? That's going to be an open circle, right? So go over to 4. 1, 2, 3. There's an open. Okay. Now, if x is less than 4, what's the other point that I'm going to use? Could I use negative 6? Yeah, because negative 6 is less than 4. Could I use negative 100? Yeah. Could I use negative infinity? Yeah. So since I only have the 1, it's going to be a ray. Does that make sense? Okay. Now, problem is, where's it going? I know it's less than 4, so I know it's going to be heading somewhat in this direction. Agreed? Because that's going less than 4. But I don't know how the line's going to look, right? So 2 ways you could think about it. Let's put in, pick a number less than 4. Come on, give me a number less than 4. That's going to be on my graph. A little further than away from 4 than 3. Hmm? 1? Will that work? Okay. So that makes 2 times 1 minus 5. That's going to give me negative 3. So at 1, negative 3 is going to be a point. Is that going to give me my enough of a definition to be able to draw my line? Yeah, it should. What's another way you could have done it? Look at my equation. What do I know from my equation? What's one point from the equation that I know? What's my y-intercept? Negative 5. So I could have used that point as well. Okay? Either way is going to work. So that's going to draw my arrow. Good? Okay. Now, for greater than or equal to 4, I'm just negative 6. So that means my point is 4, negative 6. So at 4, I'm at negative 6, and it's a closed dot. I'm looking at everything greater than, so it's going to go that way. What kind of line is that? Well, if x is 8, what's my y going to be? Negative 6. Because it's any number is going to be negative 6. And so my line is just going to go that way. Good?